welcome to another math video from your friendly neighborhood math teacher, math friends. We are here to look at triangle congruence statements, but shortcuts. So the overall idea behind triangle congruence is it allows us to show that two triangles have corresponding congruent angles and corresponding congruent sides. When we're thinking about shortcuts, though, what we're trying to do is come up with the least amount of information possible. And there are 5 that are used, listed down the left-hand side. And if we have the proper arrangement of information, we are able to write a triangle congruence statement, such as this one. AB and FE are congruent. BC and ED are congruent. DF and CA are congruent. We have all 3 sides paired up as congruent statements, and then we match the corresponding angles A to F, E to B, C to D. And then if we have side angle side with this arrangement, these are the relationships between the congruent angles and sides. Angle side, when we're talking about the non-included side, what does non-included mean? Well, the congruent angle pairs are here, AB, and here, ED. The non-included sides are either BC or AC in triangle ABC, or EF and DF in triangle DEF. Angle side angle is closely and easily confused, but the difference is we use the included side, and there is only one included side here. And then HL, hypotenuse leg, requires there to be right triangles present. And then we're able to apply this, and you may use either leg. So we always use the hypotenuse, the longest side, across from the right angle. And then either pairing works. So in this case, AB and DE. Now, we have additional information that allows us to show triangles are congruent. Most of it is prior knowledge. Some of it you could consider hidden. So prior knowledge such as vertical angles, prior knowledge such as parallel lines cut by a transversal with alternate interior angles, those must be congruent. Again, the lines have to be parallel, and sometimes other angle relationships with transversals and parallel lines like corresponding angles are also congruent. And this one is a little bit new, and you might consider it hidden, certainly non-obvious. But if we have 2 triangles that have an overlapping side, then those triangles have a congruent pair of sides because they're the same side. They're the same thing. They are equal. So here, just using plain text, AB in one triangle is AB in the other triangle. What are some examples of these? Well, we have practice here for 6 problems. Number 1, number 3, number 2, and number 6 all utilize vertical angles. So we have vertical angles here. These 2 angles are formed by the line segment here and here. These 2 angles by this line segment and this line segment. These 2 angles are congruent because we have this line segment and this line segment. And then finally in number 6, we have these 2 angles congruent because this line segment and this line segment form those angles. And then we have the reflexive property where we have shared sides in numbers 4 and 5. So we have 2 adjacent triangles sharing this side. And in number 5, we have 2 adjacent triangles sharing this side. So with this additional information, we are able to make claims about the congruent nature of these triangles. So in the first example, number 1, these triangles are in fact congruent. Why are they congruent? Because we can apply side angle side. We have 2 pairs of congruent sides. Check, check. We have 1 pair of congruent angles that is included between the sides. Check, check. Side meets here, included, side meets here, included. Side, angle, side. We have in number 2 an example of congruent triangles based on angle, side, angle. Why angle, side, angle? Well, 2 pairs of congruent angles, these two, so here to here, and then the included sides, the side connecting these angles with the side connecting these angles. Angle, side, angle. 2 triangles are congruent, 2 pairs of congruent angles, and the included sides. And number 3, we have an example of angle, angle, side. Why do we have angle, angle, side? We have angle, angle, side because 2 pairs of congruent angles, once again, 1 pair, 2 pair, and then the congruent side pair not included. This side does not connect these 2 angles. Angle, angle, side. Number 4. This is an example of side, side, side. We have 3 pairs of congruent sides. Number 5. This is an example of HL, hypotenuse leg. So we have right triangles, and then we have the shared hypotenuse and 1 pair of congruent legs. And then the final example here in number 6, we have an example of angle, angle, side. 2 pairs of congruent angles, 1 pair the vertical angles, the other pair the given angles, 1 pair of sides that does not connect the angles. The non-included side makes this angle, angle, side. Hope you enjoyed this introduction to triangle congruence shortcuts. Happy math.